Search and rescue crews continue to look for survivors in the US state of Kentucky, where record flooding has wiped out entire communities. At least 28 people have died, although the state's governor warned the number could rise.
The Appalachian Mountains were supposed to be asleep forever. Weathered, ancient, peaceful. But what scientists just found suggests these mountains might be stirring again, and what that means for the future of North America has experts sounding alarms for hundreds of millions of years. The Appalachians have been a symbol of geological stillness. Rounded peaks, soft ridges, slow erosion, a far cry from violent upheavals like the Rockies or the Andes. But now, for the first time in recorded history, satellites are detecting something no one thought possible. The ground is rising, and it's rising fast. It all began when a series of synthetic aperture radar satellites, tools so sensitive they can detect millimeter shifts in the Earth's surface, started picking up changes across the central Appalachian region. At first, the readings looked like noise. Then the pattern emerged. The crust beneath West Virginia, eastern Kentucky, and parts of Tennessee had lifted more than 12 centimeters in less than a week. To most people, that number sounds small, but in geological terms, that's explosive. Mountain ranges usually change by millimeters per year, not centimeters in days. Something deep underground was pushing upward, and no one knew why. Geologists were stunned. The Appalachians were supposed to be tectonically dead, a relic of an ancient collision, slowly eroding away. Instead, they were behaving like a restless giant waking from a long slumber. To understand why this is so alarming, you need to know the history buried beneath these mountains. The Appalachians formed over 300 million years ago. When continents slammed together to create the supercontinent Pangaea, that collision left behind deep scars, fault lines, and sutures locked into the crust. For eons, those wounds were silent. Scientists considered them fossilized, incapable of movement. But now, with the crust rising again, geologists are asking the unthinkable. Is that ancient scar reactivating? Could the forces that once built mountains the size of the Himalayas be stirring again under the eastern United States? Several theories are on the table, each more unsettling than the last. One centers on mantle plumes, massive upwellings of hot rock that rise from deep within the earth, pushing against the crust. It's the kind of process behind Yellowstone and the East African Rift. If something like that is happening under Appalachia, it would mean volcanic forces are not just alive, but active, in a region assumed dormant. Another possibility is delamination. When the bottom layer of the crust peels away and sinks into the mantle, when that happens, the lighter crust above rebounds upward like a cork released underwater. This process has been seen in the Andes and the Sierra Nevada, but never in the eastern US. If it's happening here, it could mean the entire geological architecture of Appalachia is being rewritten. There's also the post-glacial rebound theory, the idea that land still adjusts long after Ice Age glaciers melt, but experts say the timing and speed don't fit. Most rebound in North America has already slowed to a crawl, and Appalachia was barely glaciated compared to Canada or the Midwest. Whatever the explanation, none are comforting. Each suggests massive forces are in motion beneath the surface. And if the crust is moving, the risk isn't just academic, it's seismic. The Appalachian region is crisscrossed with ancient fault lines, many poorly mapped and rarely studied because they were considered inactive. But when ground rises this quickly, stress builds along those faults. Already, sensors are picking up clusters of tiny tremors, micro-earthquakes. Barely noticeable at the surface, but often precursors of something larger. History offers a chilling reminder. In 1811, the New Madrid seismic zone, another quiet area of the US interior, suddenly unleashed a series of quakes so powerful they rang church bells in Boston and made the Mississippi River flow backward. Could Appalachia be heading for its own version of that nightmare? Scientists don't know, but the possibility can't be ignored. This isn't just a scientific puzzle, it's a real-world threat. Major cities and towns lie within the Uplift zone: Roanoke, Charleston, Knoxville. Millions of people, highways, bridges, pipelines, and power grids were all built on the assumption that Appalachia was geologically stable. But Uplift can warp rivers, crack foundations, destabilize dams, and even bend pipelines. Imagine water systems suddenly rerouting, reservoirs shifting, or highways buckling. And if seismic activity follows, the risk multiplies. The region's infrastructure wasn't designed for earthquakes. What makes this even stranger is that, looking back, there were warning signs, but no one connected them until now. Over the past decade, isolated reports trickled in. Spikes in radon gas levels in valleys, unexplained fissures in the ground, tiny tremors that didn't match known faults. Recently, scientists also detected unusual ratios of helium-3 gas in mountain springs, a rare signature, usually linked to material rising from deep in the mantle. Even the magnetic field seems to be shifting slightly in the uplift zone, suggesting minerals underground are being physically displaced. One anomaly alone might be ignored, but taken together, they paint the picture of something far bigger and far stranger happening beneath the Appalachians, and people are starting to notice. Homeowners are reporting cracks in walls and driveways. Damage once blamed on aging structures, but now re-examined as possible signs of ground instability. Schools in the region are holding earthquake drills for the first time in living memory. Insurance companies are quietly reassessing risk maps. Energy companies, whose drilling operations depend on stable ground, have paused projects in the uplift. Zone engineers worry about pipelines bending or snapping under new stresses. Even the natural world is responding. Botanists are tracking unusual bloom cycles in plants. Ecologists are observing wildlife migrations shifting unpredictably. Amphibians are breeding in new patterns. It's as if the ecosystem itself senses the land beneath. It is changing. What's most haunting is how this moment echoes old legends. Native American oral histories once described the Appalachians as sleeping giants that could stir when the balance of the world was broken. For centuries, those stories were dismissed as myth. Now scientists are taking a second look, not because they believe in giants, but because oral traditions often preserved observations across generations. Maybe those tales were warnings about patterns of rare but recurring geological events. If so, what we're seeing today could be part of a much longer cycle, one humans forgot, but the land remembers. Zoom out, and the mystery only deepens. Other ancient mountain ranges, like the Urals in Russia or the Scandinavian remain quiet. So why Appalachia? Some experts think the entire North American plate may be under new stress. Forces from distant subduction zones, or even changes along the mid-Atlantic ridge, could be sending shockwaves across the continent, reawakening old scars. If that's true, then Appalachia might just be the first place to show visible cracks, and over millions of years, that could mean something even bigger. The slow birth of a new continental rift. A process that could eventually tear North America's eastern edge apart. For now, all anyone knows for sure is this: the ground is moving. The Appalachians, once thought to be in their geological grave, are rising again. No one can yet say whether this is the start of a new mountain-building era, a precursor to earthquakes, or simply a mysterious anomaly that will fade away. But one truth is undeniable. Even the oldest landscapes on Earth are not as still as they seem. If mountains that slept for 500 million years can suddenly stir, what else beneath our feet might be waiting for its turn? 3 main theories are circulating, and none offer comfort. The first is the mantle plume theory, that a mass of superheated rock is rising from deep in the Earth, pushing the crust upward. It's the kind of process behind Yellowstone. If true, this could be the first hint of volcanic forces under Appalachia, a place where no one has ever prepared for eruptions. The second is delamination, when the lower crust peels away and sinks into the mantle, forcing the lighter rock above to rebound. In the Andes, this process triggered major tectonic shifts and volcanic bursts. If it's happening here, it could reshape Appalachia's geological architecture for good. The third theory is post-glacial rebound. The idea that the crust is still adjusting after Ice Age glaciers melted, but experts are dismissing it. Appalachia was barely glaciated, and the speed of uplift here dwarfs anything linked to glacial rebound. So what's left? Something new, something we don't yet understand. If the crust is moving, stress is building, and stress doesn't stay hidden forever. Already, seismographs are recording a spike in micro-earthquakes. Tremors too small for most people to feel, but enough to raise alarms. These are often the whispers that come before the roar. The danger is that Appalachian faults are old, brittle, and poorly mapped. No one knows exactly where they run. And history has already shown us that quiet regions can snap violently. In 1811, the new Madrid seismic zone, thought to be inactive, unleashed quakes so massive they cracked the Mississippi River and rang church bells in Boston. If something similar struck Appalachia, millions of people could be caught off guard. The risk isn't just earthquakes. The very act of land rising threatens infrastructure. Knoxville, Roanoke, Charleston cities, built on the assumption of geological peace, now find themselves in the uplift zone. Pipelines carrying natural gas. Search and rescue crews continue to look for survivors in the U.S. state of Kentucky, where record flooding has wiped out entire communities. At least 28 people have died. Although the state's governor warned the number could rise, a sudden and unexpected geological phenomenon has sparked alarm across the scientific community, as satellite imaging has revealed an unusual and rapid uplift occurring deep within the Appalachian Mountains. This ancient range, known more for its steady erosion and long geological stillness than for violent upheaval, is now showing signs of accelerated vertical movement, a development that has led geologists to issue a rare red alert. This level of warning is almost unheard of in the context of the Appalachian, a region historically considered geologically stable. But the data is undeniable. The crust is rising, and it's happening fast. Before we start, smash the like and subscribe buttons for more updates. The alarm was first triggered when a sequence of synthetic aperture radar SAR satellite passes over the eastern United States, registered subtle but significant changes in ground elevation. These satellites, equipped with advanced interferometry capabilities, can detect vertical land movement down to millimeter precision. Over the course of several days, a pattern emerged. The crust beneath a wide swath of the central Appalachian region, including areas spanning West Virginia, and parts of eastern Kentucky and Tennessee, had risen by as much as 12 centimeters in less than a week. In geological terms, this is nothing short of explosive. Such rapid uplift is not characteristic of the Appalachian Range, which has been in a long passive phase for hundreds of millions of years. Formed during the Paleozoic era, the mountains once rivaled the Himalayas in size, but have since been worn down into gentle slopes and rounded ridges through eons of erosion. That makes this recent activity not just unexpected, but potentially transformative. The phenomenon suggests that forces deep beneath the crust, long thought dormant in this region, may be stirring once again. Geologists are now questioning the stability of the tectonic forces underlying the eastern seaboard of North America. The Appalachian Mountains sit atop a deeply buried and ancient collision zone, remnants of the supercontinent Pangaea. These old sutures have been locked for hundreds of millions of years, but the possibility that they could be reactivating carries significant geological consequences. One leading hypothesis centers on mantle dynamics. Some researchers believe that a buoyant plume of hot mantle material could be rising beneath the lithosphere, exerting upward pressure on the crust and causing it to flex and lift. This kind of movement has been observed in places like the Yellowstone caldera and the East African Rift, areas known for active volcanism or continental rifting. That such a process could be occurring beneath the Appalachian, long considered tectonically dead, challenges decades of conventional thinking. Another possibility is related to the phenomenon of delamination, in which the lower crust or mantle lithosphere peels away from the overlying rock and sinks into the mantle, prompting the remaining crust to rebound and rise. This has been observed in the Sierra Nevada and parts of the Andes, but never before confirmed in the eastern US. If such a process is now unfolding beneath the Appalachian, it could mark the beginning of a major reconfiguration of the regions. Geological architecture, even more speculative but impossible to ignore, is the idea that this uplift might precage deeper, more dangerous seismic activity. Though the Appalachian region is not known for frequent or high-magnitude earthquakes, there are fault systems running through the area, many of which are poorly mapped and only partially understood. Rapid crustal movement introduces stress into these ancient faults, potentially setting the stage for slip events. Already seismographs in the region have recorded a noticeable uptick in microseismicity, tiny tremors that could be a harbinger of larger quakes to come. Compounding the concern is the breadth of the uplift zone. This is not a localized anomaly, such as one might expect from subsurface fluid injection or natural gas extraction, which are known to cause surface deformation. Instead, the uplift is distributed across a broad geological footprint, suggesting a deep-seated and systemic force at work. That has major implications, not just for geologists, but also for urban planners, infrastructure experts, and emergency management officials across the eastern United States. Many towns and cities lie within or near the affected region, including Charleston, Roanoke, and Knoxville. Places where population centers and critical infrastructure could be vulnerable if the uplift accelerates or triggers seismic activity. Bridges, highways, pipelines, and power lines built under the assumption of geological stability are now potentially at risk. The red alert issued by geological authorities is meant not only as a scientific signal, but also as a call to preparedness. Water systems could also be affected. Ground uplift can alter the flow of rivers and aquifers, potentially leading to flooding in some areas and water shortages in others. Uplift changes watershed topography, and even subtle shifts can divert streams or stress dam systems. The Appalachian region is home to numerous reservoirs, hydroelectric facilities, and major river systems like the Tennessee and New Rivers. Any long-term vertical movement could fundamentally reshape these water systems in ways that could take years or decades to fully grasp. Adding to the urgency, the satellite-detected uplift has continued to trend upward since its initial detection. Each subsequent satellite pass adds to the growing body of data, suggesting the motion is not leveling off, but rather continuing, albeit at a slightly slower rate than the initial spike. This steady rise contradicts early theories that it might be an elastic response to seasonal changes, glacial isostatic adjustment, or groundwater extraction. The pace, direction, and uniformity of the uplift all point toward a deeper geodomic process. If mantle dynamics are at play, one consequence could be the gradual weakening of the lithosphere in this region. Over time, this could lead to the formation of a rift, a split in the continental crust that, while not likely to occur overnight, could profoundly affect the geological map of eastern North America over millions of years. The appearance of rift-related features such as linear faulting, volcanism, or increased seismicity would signal a tectonic regime change unlike anything the region has seen in 500 million years. There's also the question of how this event fits into the larger narrative of global tectonics. Other ancient mountain ranges, such as the Urals in Russia or the Khetanides in Scandinavia, have shown no similar signs of renewed tectonic activity. So why the Appalachians? Some geologists speculate that the North American plate may be undergoing subtle changes in its stress regime, possibly influenced by distant subduction zones or shifting boundary conditions near the mid-Atlantic ridge. These changes might be reactivating long-buried weaknesses in the continental interior. Whatever the cause, this event is redefining how scientists think about so-called passive regions of Earth's crust. The notion that ancient eroded mountain belts are permanently dormant is being challenged by this unfolding episode. It's a stark reminder that even landscapes which appear tranquil on the surface can conceal powerful tectonic forces biting their time in the deep earth. The timing of the uplift has also caught attention. Over the last decade, there have been scattered reports of odd geological activity in the region. Increased radon gas emissions in certain valleys, minor tremors that don't align with known fault systems, and the occasional appearance of new fractures or ground fissures. Until now, These events were mostly dismissed as isolated anomalies. But in light of the new Uplift data, geologists are revisiting these occurrences with fresh eyes, searching for connections that may have been overlooked. Another facet drawing intense scrutiny is the thermal profile of the region. Satellite-based infrared surveys and ground-based geothermal sensors are now being cross-referenced with Uplift data to determine whether a thermal anomaly is present beneath the crust. An uptick in subsurface heat could suggest the presence of an upwelling mantle plume or localized magmatic body, either of which would significantly raise the stakes of this geological event. Preliminary temperature readings from deep boreholes appear to show slight deviations from historical averages, not enough to confirm active magmatism, but enough to warrant further investigation. This new activity is also igniting debate over the role of isostatic rebound in the Appalachian uplift. Some researchers suggest that post-glacial rebound, the slow rise of the crust after the melting of massive Ice Age glaciers, could still be affecting this region. Yet, this theory has limitations. Most post-glacial uplift has already slowed to near imperceptible levels across North America, particularly in regions like the central Appalachians, which were only marginally glaciated to begin with. The scale and speed of the current uplift appear to exceed what would be expected from isostatic adjustment alone. Even as scientists race to understand the origins of the uplift, they are also preparing for its possible consequences. The Red Alert has mobilized geological monitoring teams, accelerated funding for deep Earth imaging studies, and prompted emergency drills in some of the larger urban centers within the uplift zone. A coordinated response involving the USGS NOAA, NASA,